Hey, hello guys, this is Shubhabroto and welcome back to my channel circuiTician. We came back here after a very long time, and on that time we are giving training to the engineering graduates in various engineering colleges. While giving training, we have noticed that most of the students doesn't have the basic knowledge about electronics and robotics. Students don't know how a servo motor works or how a stepper motor works or how to wire up the sensors in the breadboard. So they faces many difficulties in the advanced stages of the IoT and robotics training or the electronics training. So we have decided to start a session in our YouTube channel about the basics of electronics, basics of microcontrollers and the embedded system and the robotics. So in this video we will teach you about what is embedded system, what is microprocessor and microcontroller and the basic differences between them, and what is logic level, type of input and output, what is input, what is output, these all the things. So don't skip the video, watch till the end. Let's get started. So first we will discuss about what is an embedded system. If I say a definition, so embedded system is a specially designed system or a computer system to do a specific task with less amount of resources. I want to give an example like an induction oven. It is an example of a embedded system. Like there we have to give some certain inputs like temperature and timers, and the system will automatically control the heating mechanism and the timing section. So it is a very good example of an embedded system. Rather than this, we have washing machine, microwave. These all are the example of embedded system. Now we will discuss about microprocessor, microcontrollers and difference between them. And I am trying to explain all these things by giving real life examples. Like when you are going to a shop to buy a desktop PC or a laptop PC, you will ask the shopkeeper or the seller about the processor. So this is the microprocessor, like a Intel processor or a AMD Ryzen processor. So processor needs peripherals like RAM, ROM, and ROM means SSD or the hard disk, need these things to work. But the microcontroller doesn't need, microcontroller doesn't need any external RAM or ROM to work. It can work alone. So the basic difference is microprocessor needs external RAM and ROM to run, but the microcontroller doesn't need the external RAM and ROM because the RAM and ROM is inbuilt within the microcontroller along with the processing unit. So there is the first difference. And microprocessor is designed to do various type of works. Like in a PC you can play games, watch videos or design any circuit or any type of designs. Okay, but the microcontroller is designed to do a specific job. Like before I said the induction oven heating system or a micro oven system or a washing machine system, because we cannot play games in the washing machines. So this is also a difference between the microcontroller and the microprocessor. As we will be working with the microcontroller system or the embedded system, we need to know what is input and output. But before dig into the deeper, I want to ask one question, that what are the input and output system to a desktop computer system? Pause the video and comment the answer below. Okay, we are done. So the input devices of our desktop system is a keyboard and mouse, and the output device will be a monitor, and if we connect any speaker system or sound system, so that will be also a output device to the desktop computer system. Now you will be wondering that sensor is what type of device? Sensor is the input type of device because microcontroller takes input from sensors. Okay, like what is the temperature, what is the air pressure, this kind of thing. So the sensors is the input device to the microcontroller system or embedded system, and all type of lights, display, motors, any type of pneumatic actuators, relays, all these things are output device to the microcontroller system or to the embedded system. As we have discussed about input and output type device, now we need to know type of input and output. In generally, there is two type of input and output, that is digital type input output and analog type input output. So what is the example of digital type input? Any button or any switch can be considered as a digital type of input. So now what is digital input? Digital input has two states, 1 and 0, or rather you can say on or off. So you can on a switch or off a switch. So there is two states of the switch, so it is a digital type of input. And in case of push buttons, you can press the push button, press and hold a push button, and you can release the push button. So there is also two states. So it is also an example of digital type of input. So what is the digital type of output? I want to give an example of LED. Can be in two states, on or off. So here is also we can visualize two states. So it is also a digital type of output. Now come to the analog type of input output. Analog signals or analog input and output doesn't have two states. It has infinite number of states. So in case of analog input, we can give an example of a potentiometer control or a volume control, you can also say. So there is a variable resistance by which we can give analog input to the microcontroller system, or a very good example will be a temperature sensor or a pressure sensor, from which microcontroller take analog readings like 30 degrees centigrade, 31 degrees centigrade. There are multiple number of states, so there is no specific two states. So these sensors are also analog type of sensors, and it means analog type of input signals. And for analog type of outputs, we can consider a speed controlling of a motor, or brightness controlling of a display or LED light. Because controlling the speed, there is multiple number of steps, like from 0 RPM, 1 RPM, 2 RPM to the maximum RPM. And for the brightness level, it is also the same. From minimum brightness to maximum brightness, there is various number of states. So these are the example of analog type of outputs. As I have said before, that we have two states in digital type of input output, that is 1 and 0. So what it is mean in real world, what is 1 in real world and what is 0 in real world in terms of voltage, power, current, etc. 0 means 0 volt or ground, and 1 means, for some microcontroller 1 means 5 volt, and for some microcontrollers 1 means 3.3 volts. So it is defined by the logic level that 1 will be 5 volt or 3.3 volt. So here we heard a term logic level. So what is logic level? Logic level is the maximum voltage for the logic 1, and that thing is called logic level. For the Arduino microcontrollers, the logic level is 5 volt, and for the ESP microcontrollers, the logic level is 3.3 volt. Because as the Arduino is older than the ESP boards, so Arduino uses 5 volt of logic levels. Most of the old microcontrollers uses 5 volt logic level, and the new microcontrollers which are upcoming and now running, like ESP32, ESP8266, and this type of microcontrollers uses 3.3 volt logic level, because the microcontrollers power consumptions are very less, so it uses low level of voltages. So here are three breadboards: mini breadboard, small breadboard, and standard breadboard. But I would recommend you to buy the standard breadboard, because if you buy the mini and the small breadboard, you will waste your money. Why I am recommending this standard breadboard? Because if you want to make circuit along with the microcontroller, so you can make the circuit on the standard breadboard. So don't buy this small and mini breadboard. Okay, now let's understand how this standard breadboard works. Here are some points you can see. So the points like A, B, C, D, E in a column is connected together, and the point in F, G, H, I, J is connected together. So like this, all the points in a column, all the 5 points in a column is connected together. Now coming to the upper and lower portion points. Here you can see there is plus and minus symbol. So these connections are called power rails. So all the points in the minus row is connected together and all the points are in the plus row connected together. So these two rows used for giving the powers to the breadboard, and we can use these two rails for powering all the circuits throughout whole the breadboard. Okay, and this connection is same for the lower portions also. Here you can see in the lower portion there is also minus and plus symbol. For understanding the breadboard connection properly, we will do some experiment. Most of you heard about the term logic gate. So today we will make the logic gate circuit using some buttons in the breadboard. This step is very important because you should know how to make a circuit in the breadboard by seeing a circuit schematic. So here are the circuit schematic for AND gate and OR gate. And here we are not using a traditional 7-4 series ICs. Instead we are using some push buttons and a LED for the output. And these are the truth table of AND gate and OR gate. So here first we will make the circuit of the AND gate. So this is the breadboard and this is to double a battery 1.5 volt. So here we are using totally in 3 volt because the battery is in series. Here we are using two slide switches and one 220 ohm resistor and a LED for the output. So now we will connect the switches to the breadboard like this. We will put two switches. Now we will connect the positive of the battery to the center point of the first switch. And I am making the color of the wire red. Then the second point of the switch 1 will connect to the center point of the switch 2. So both the switch are in series connection. After that, we will connect the 220 ohm resistors one end to the second point of the second switch directly in the breadboard. After that, we will connect the LED anode to the another end of the 220 ohm resistor, and I am connecting this LED directly to the resistor. I am using no wires, no extra wires. After that, the cathode of the LED will be connected to the negative of the battery supply or power supply, and I will make the negative wire color to the black for your better understanding. Now if I turning off both the switches, so light will not glow. If I am turning on both the switches, then the light will glow. Now I am started the simulation and I am turning on the switches one by one. I have turned on the first switch and now the second switch, so the light is glowing. If I turn one of the switches, one of the any switches, so light will get turned off because it is AND logic gate, and for that reason the switch is connected in series connection. So this is the AND gate logic circuit. So you will make it in the physical breadboard. Now we will make the circuit of OR gate in the breadboard. So in the OR gate circuit, the switches are connected in parallel. So for that reason, we will connect the positive of the battery supply or power supply to the center point of both the switches. And I am making the wire color red as it is from the positive pin of the supply. Now we will connect the second point of both the switches together. And from that point we will connect a 220 ohm resistor, and the another end of the 220 ohm resistor is connected to the LED, and the LED cathode is connected to the negative of the power supply. So our circuit is complete. Now I am started the simulation. Here you can see both the switches are on. For that reason the LED is glowing. But here if I am turn off one switch, the LED will still glowing, but to turn off the LED we have to turn off both the switches because this is an OR gate circuit. So in OR gate circuit, if one of the switches is on, then the LED will glow or the output will be 1. So this is how a OR gate circuit works. Now I hope that you can very easily make circuits on the breadboard without doing a short circuit. Okay, let's move on to the Arduino framework. So what is Arduino framework? Actually, it is a special type of toolbox which consists various type of Arduino development boards from beginner to advanced level and a software called Arduino IDE. And nowadays there is also a thing called Arduino IoT Cloud. More on them later. So in the Arduino IDE, you can write the program using C and C++ codes. So in most of the cases, it will be very easier to write the code in Arduino IDE. So we have come to the end of this video, and I hope you like this video and learn something new. And I will be back soon with new videos on embedded systems, especially on Arduino and ESP board. To get notified about my video, do subscribe to my channel and click the bell icon and like this video, share this video with your friends and technical community. And if you want to support my effort, then you can buy me a coffee. Link is given in the description below. And the most important thing, be creative.